Welcome to the project demonstration of solar power air conditioning system by using thermoelectric effects. So here we are using Peltier plate which we mounted inside this heat sinks, so which will taking care of thermoelectric effect. So the main purpose of this thermoelectric effect will be achieved with help of Peltier plates. So the main purpose is like it will transfer the heat from one surface to another surface. So this side of the Peltier plate is heating plate and inside that cooling plate. So we have mounted the DHT11 temperature sensor along with air purification chamber, so which will take the air inside this chamber and recirculate that. When we are recirculating the air, there we use the carbon filters along with dust filters which will purify the air inside this chamber. So based on the temperature, we are going to set the temperature. If you want to less the temperature than the room temperature, then by using this potentiometer, we set the temperature. For example, if the room temperature is 22 degrees centigrade, but if you want to 20 degrees centigrade, we need to set that with help of this potentiometer till reaches that 18 degrees centigrade, till reaches the set temperature. The system will keep on the thermal effect by on this Peltier plate with help of this electromechanical relay. So when it's getting switched on, then the Peltier plate will get supply, then it start transfer the heat from another side to the this side, means inside of the heat will be transferred to the outside, and that will be dissipated to the air with help of this cooling fan. So that when the heating is occurred on this aluminum plate heat sink, then that will be dissipated. We have to dissipate that, otherwise the Peltier plate will get damaged. So that supply is given from this 12-volt battery, that is rechargeable battery. We can recharge this battery through the solar panel directly. So when we are demonstrating this using solar panel, just we need to connect the S at this T and S slots. So now the battery is charging with help of this solar panel. When we place this under sunlight, the battery will be fully charged in a duration of 6 hours. So if there is no sunlight is available, but if you want to charge a battery, then disconnect the solar panel in absence of sunlight and connect the T transformer at the same slot, and now on the power supply to the transformer, so that the 230 volts AC will be stepped down to 12 volts AC and 12 volts DC after this regulated power supply board. So the battery will be fully charged in a duration of same 6 hours. So after the 6 hours duration, automatically this charging circuit will block the current flow from the battery to the charging circuit. At the same time, it will block the current flow from the transformer to the battery in order to protect the battery from the overcharging. So once time completion, you can disconnect the charging cable and now connect the solar panel while main project demonstration. So this is the main on-off switch for the supply of the whole system. So when we on that, 12 volts DC is the input to the LM2596 regulator, because we need 5 volts power supply to operate this input and output modules. So for that purpose, we need to regulate the 12 volts DC to 5 volts DC with help of LM2596 regulator. So once we provide the 5 volts to this one, it start reading input from the two input sensors. One is potentiometer for threshold value set, and another is a DHT11 to measure the humidity and temperature continuously. So whenever the set temperature is less than the room temperature, then it will switch on this relay, and then the system will cool down the room temperature. So let us see the demonstration. When we on this, a welcome message will be displayed on the LCD screen, and then it start keep on displaying the room temperature. The starting line is the chamber temperature and humidity. This 25 degrees centigrade and 50%, and set temperature is 27. So as set temperature is greater than the room temperature, that's why the relay is off state, but this fan continuously on. So this is a main secure like cooling device. It should be on continuously. So let us decrease the room temperature. So I kept it around 25. Right. So high temperature messages are displayed on the LCD, and the cooling was done happen. You can sense just by holding this cooling aluminum plate. So meanwhile, we'll explaining the right. You can see that the temperature is slightly decreasing. Right. So meanwhile, I explained the connections. We have interfaced the DHT11 sensor at C0 pin of our PIC16F72 microcontroller, and this set temperature is connected to A0 pin, and port B, that is a B2 to B7 connected to the 16:2 LCD screen, and relay is connected the 7th pin. So right. Again let me decrease some more. Right. We can observe the humidity and temperature also keep on decreasing. So coming to the battery ratings and solar panel ratings, we are using 12 volts 10 watt solar panel, and the battery ratings are, so here we can see the 3 batteries are connected. So these 3 are connected in series, so we will get the V1 plus V2 plus V3. So the V1 voltage is 3.7 volts, 2600 milliamps of current will be produced from these batteries. So these 3 are in series, so we will get 2200 milliamps with 12 volts. Right, we can see the temperature was decreasing. Right, so in this manner we are going to achieve the solar powered air conditioning system by using the Peltier effect, the thermoelectric effect.